All right, let's look at the homework 11.5, problem number 8. All right, so we have this alternating series here, and we want to find the Bn first. So Bn, just you strip off this -1 to the n. So you're going to get 1 over n times 6 to the n. All right, so maybe I'll do that. All right, let's check the answer. Submit for testing. All right, we got this one correctly. All right, then let's find the limit of Bn as n approaches infinity. But this one is very simple because you have a 1 over, the denominator gets larger and larger. So 1 over infinity, which is going to be equal to 0. All right, submit for testing. All right, we got the limit correctly. So since the limit of Bn as n approaches infinity equal to 0, and you can see that this is a decreasing sequence. So Bn plus 1 is going to be smaller than or equal to Bn for all n. By alternating series test, we know that this is convergent. All right, let's check the answer here. All right, looks like we got all three correctly here. All right, next one. If the series is convergent, use the alternating series estimation theorem to determine how many terms we need to add in order to find the sum with error less than 0.0001. All right, so remember that the error for alternating series is, so error would be always bounded by so this error, maybe I should be a little bit more specific. Say using the only the first n elements, so we're going to use a partial sum as the estimate, and this is going to be bounded by Bn plus 1. Right, so what we want to do is we want to make sure that this is going to be less than 0.0001. Let's see, let me double check. All right, it's at 0.0001. All right, so this is what we want to do. All right, so let's just say, so this is Bn right here. All right, then I'm going to use the GeoGebra here. All right, and I'm going to just define n. So I'm going to just put n equals 1 first. Right, then I'm going to define Bn to be 1 over n times 6 to the n. I hit enter. All right, first I have to change that to a decimal number. So go to object property, so then put symbolic. All right, and also I have to go to option and rounding to say 5 decimal places. All right, so when n equals 1, it's not big, it's too big. Error is going to be too big. So how about the n equals 2? All right, so it's getting smaller. How about the n equals 3? All right, getting there. How about n equals 4? All right, so it's almost there. So we try n equals 5. All right, so then it becomes less than 0.0001. So n equals 5 is good. In this case, actually, when n plus 1 equals 5, you're going to have the sufficient accuracy there. So what we can do is we can add all the way up to a fourth term. So we can do, so first term would be, once it's a negative, 1 over, right, 1 times 6 to the 1, right? So that's the first term. So next term is going to be plus, right? Then you have 1 over, right, 2 times 6 to the 6 squared. Right, next one is minus 1 over, right, 3 times 6 to the third power. Right, so that's the third term. So we're going to add up to fourth term. So it's going to be plus 1 over 4 times 6 to the 4th power. All right, so this is going to be the S4. I'm going to call it the S4. All right, so that. All right, and again, I have to change that to right-click, Object Property, and then uncheck the symbolic. All right, so you can see that S4 is going to be negative 0.15413. So what's the accuracy there? All right, so we actually we didn't have to actually do this. Less than, so we need to add. Let's see, how many terms we need to add. So answer is 4. All right, so let's check the answer. Submit for testing. All right, we got this one correctly. All right, that's it. I hope that this was clear.